Hello everyone, welcome again. So we're talking about hash function and the hash function can create collision. Now in this segment we are going to see the how we are going to find the resolution for the collision. So the simple hash function is the key mode table size. Okay, so this is the most general strategy to find the hash function, to find the hash value. Now if the input key is a integer, in that case this is the, if the input key is integer, this is the general strategy. Now if the keys are string, in that case we have to actually find the hash function more carefully. One strategy could be, first we can convert it to a numeric value. All right, so in last segment we talked about collision and what does collision means. Okay, so when we are inserting the elements, if it hashes to the same value as already inserted the element, then we have a collision, and in that case we have to resolve it. So there are several methods for dealing with the collision. So the first one is known as separate chaining, and then we are going to see what is the problem of separate chaining, and then we are going to see that another technique known as open addressing. Okay, the separate chaining is actually simple. The idea is to keep a list of all elements that hash to the same value. Okay, the array elements will be a pointer to the first node of the list, and the new item is inserted to the front of the list. So let's see how it is going to look like. So let's say this is our hash function. Okay, so the key value is 0. We're going to insert it in 0. Now we are not going to insert 0 in the array. What actually we are going to do, we are going to the array elements will be a pointer. Okay, now the array elements, we are not going to insert the key as a array elements. The array elements will be a pointer to a list, or we can say chain. Okay, array elements will pointer to a chain. A chain, it is nothing, just a linked list. Okay, because a linked list is the flexible in size. Okay, it can grow or shrink whenever we want. Okay, insertion and deletion, it is not going to take additional space. It can grow or shrink anytime. All right, so the array elements will be a pointer. Okay, and this pointer is going to point to a linked list. So you can see that when we are going to insert 0, so this list will have only one value, 0. Okay, and the index 0 is going to point to that list. Now 1. Okay, insert, so 1, so okay, insert 1 here. All right, so let's just show you how this is going to look like. All right, so the values are 0, 1, 4, 9, 16, 25. 36, 49. Okay, all right, so we have the hash table, and let's see, the size is 10. Okay, all right, so each of the array elements will be a pointer. So if that doesn't have any value, okay, it is, this pointer is going to point to null value. So but when we are going to insert 0, so 0 mod 10 is 0. So we are going to create a list where we are going to insert 0 as a front of the list. Okay, now it is pointing. Sorry about that. So 1, I'm going to insert 1 here. 0 mod 1 mod 10 is 1, so I'm going to insert 1 here now. Okay, so 4 like that. Now let's see, insert 81. Okay, insert 81. So 81 mod 10 is also 1, so that is going to create a collision. So what I'm going to do, I'm going to go to this index 1. So there I have the linked list, but I'm going to insert the new value at the front of the linked list. Okay, so this is going to now look like #81 1 now. All right, so let's see what will create a collision. 16 and 36, it will create a collision. So when I will add 16, I will add 16 here as a here 16 as a first element, then I will add 36, and then I will add 36 as the front of the list. So the list will look like this. Sorry. So yeah, now. Okay, so let's see how I'm going to find the item. So let's say I'm looking for an item 81. Okay, I'm looking for item 81. So I'm going to calculate the hash value. Okay, it will give me 1, so I'll go to the index 1, and here there is the pointer. I will follow the pointer, I will find a list, and I will look for the item in the list. Okay, so here you can see that the insertion is actually efficient, because I will calculate the hash value. I will go to the pointer linked list, and inserting a item in the front of the linked list, it's actually constant runtime. But about searching, now searching, I will calculate the hash value. I will find a linked list, and I have to actually find the item in the linked list. In worst case, I have to look for every item in the linked list. Okay, so obviously here the runtime is not going to be, it's not actually order of 1. Okay, it's actually slightly more than order of 1. But if there is not too many collision, okay, if there is not too many collision, and if the numbers key values are evenly distributed, in that case actually we can expect that this could be actually better than, even better than log of n. Okay, so this is known as separate chaining. All right, you can see how all of this value is going to be stored as the chaining. So here for example, like we don't have any index hash value created like 8, so this record pointer is going to point to this pointer, array element pointer is going to point to just null value. Okay, now what are the problems and disadvantage of this scheme? The advantage is that better space utilization for larger item, means we are doing the collision resolution, and it will create a better space utilization. Okay, I don't have to create a really large array. So for example, here you can see that if I'm going to use a one-to-one hash function like that, so the last value here is 81, means that hash table size have to be 81. But here we don't need actually that many space, so it creates a better space utilization. So this collision handling is very simple, and finding the item, we have to actually search in the linked list. Okay, and we can handle the overflow. We can store actually a lot of items in the hash table because we are using linked list, and linked list can grow or sorry, linked list can shrink and grow flexibly. Okay, it doesn't waste any space. Deletion is quick and easy. Deletion from the linked list, we know that just follow the algorithm to delete an item. And insertion is also easy. You saw that insertion takes actually a constant runtime because we are inserting at the front of the list. Okay. So here initialization, initially we are every pointer we are going to point to null. Okay, how we are going to find, we are going to locate at the cell using hash function, then we are going to use the sequential search in the linked list in that cell. So insertion means locate the cell using the hash function and insert it at the first item in the list. So deletion, we are going to locate the cell using the hash function and delete the item from the linked list. All right. Okay, so we're going to continue our discussion in the next segment.